Hello guys, welcome back to the channel. So in today's tutorial, we're going to go ahead and start a new series on introduction to machine learning with Python. So you probably heard the word machine learning, data science, AI, and all of this. So we're going to go ahead and cover what machine learning is, and machine learning is part of data science, is part of AI. Okay, so we're going to go ahead and learn, basically learn what machine learning is from the scratch using Python. At the end of the day, you're going to go ahead and build a simple project to predict the price of a car using machine learning or using AI. So we're going to use that the knowledge you're going to learn in this video to build a simple linear regression model that can predict the price of a car when given the different features of the car. So let's go ahead and get started. So what is machine learning basically? So you probably heard this term very often, like machine learning, data science, AI. So what is really machine learning? So let's to understand what machine learning is, I want to use I want to explain to you what machine learning is using an example and not just the textbook definition. So let's take a look at it. So let's ask ourselves a question, right? How do we humans learn? How are we able to learn? Okay. So for example, let's take this example of a car salesperson, right? This person is able to sell cars. So let's say John, his name is John, and John is able to sell cars. So if you go ahead and ask John what the price of a given car is, let's say this is a Toyota Civic, and then you ask sorry, a Honda Civic, and you ask John what's the name, what's the likely the price of a Honda Civic, right? So John might, using John's knowledge of working in the car industry for so many years, he can be able to tell you the price of the car. So John will probably think, okay, a Honda Civic maybe has this amount of CC in its engine, has this amount of features, is a two-door car. This is using different features of the car. John is able to tell you, can give you a rough prediction of what the price of the car is. So John can come, let's say John says, okay, these cars can go for around maybe 10k. So how did John come up with the 10k, the figure 10k? Because he has experience working in the car industry and knows that the Honda Civic with the different features it has, it can cost around this amount of price, right? Okay. So that's basically how humans work. Like, so we are able to remember data from the past, and using that data from the past, we're able to make predictions about the future, right? So that's basically how humans are able to make predictions of something of a future occurrence. Basically, in this case, we're trying to predict the price of a car, and John already knows the knowledge of cars and has a lot of experience working with cars. So he's using his past knowledge to be able to come up with a price, the rough estimate of what the car might cost. So he's using his old knowledge, right, that he has in his mind to come up with the price of the car. So that's very, very important. So how does this work? So let's say that John has a kind of algorithm or some knowledge or expertise that he gained from working in that field, right? And some knowledge about a vehicle. For example, in this case, John has some knowledge of what the Honda Civic is, the different features of Honda Civic. So using his memory and his knowledge of working in the car industry, he's able to come up with the prediction of the car when given the different specific vehicle specifications. He's able to come up with the price, the prediction of the car. So data from his mind, like his memory, combined with the knowledge that he has, like kind of like algorithm, is able to come with the price of the car when given the different specifications of that car. So that's basically how machines how machines are able to learn. So how can you program a computer to do this? Now that you have understand how humans work, can you be able to transfer the same knowledge to a computer? Basically, give features of different features of a car, and the computer will be able to tell you what the price of the car is, and that's the whole point of machine learning, right? Basically, training computers to be able to make predictions. So let's look at an example. So let's say that I have a data set where I went ahead and collected data from different vehicles. So I have the data in my database. So I'm going to feed that data to a computer which has an algorithm. Now we'll not talk about this algorithm, but these algorithms are called machine learning algorithms, and we'll look at there are a lot of machine learning algorithms. We'll look at some of them in the future in the upcoming slides. So we have data about different cars. We collect data about cars because the computer doesn't know about cars, right? So we collect data ourselves and we store the data in the computer's memory, right? And we give that data to the computer which has an algorithm which is called a machine learning algorithm. So the machine learning algorithm studies the data that you give it. So it studies the car. So let's say that we give the different features of the car and its probable price, right? So give maybe a Honda Civic. It has this amount of CC engine, this amount of where the engines are. So the machine learning is able to come up with the price of the car by studying the historic data that this car with these specific features costs about this much. So if you give the computer in the future on, if you give the computer some features, it's going to use the knowledge that it learned from the data to be able to come with the price of the car. And that's very similar to how humans work, right? So basically, we just take a bunch of data, we feed it to an algorithm called a machine learning algorithm. So this algorithm is able to study the data, the different features of the car, and how much it's likely to cost. So when the feature, when you give it some specifications that the computer maybe it has seen or has never seen before, it's going to use what it has learned from the data to make a prediction of the price of the car. So that's basically what machine learning is. You just have a bunch of data that you feed the computer algorithm, which studies the data, be able to generalize on the data, and then if you want to make future predictions, give it some specifications. It's going to take it those specifications, and using what is it has learned from the data, it's able to come with a prediction. And that's basically what machine learning basically is. So that's basically what machine learning is. So good. Once you have looked at that, let's look at the different branches of machine learning. Okay, so but machine learning has a lot of branches. So there are three main branches of machine learning. There's supervised machine learning, there is unsupervised machine learning, and there's also something called reinforcement machine learning. Okay, or reinforcement learning (RL). Okay, so let's start from supervised machine learning. So supervised machine learning, this is the type of machine learning whereby you give a computer some. Let's say that in the case of the car, right, we give the computer the features of the car along with its price. So the computer is able to study if the car has this kind of features, then its price is about this amount, right? So you have the label, you have the different features, and you also have the label. We call that the label, what you're trying to predict, right? So in this case, you're trying to predict the price of the car. So the price of the car will be our label. So we have data about the car and then the price of the car, which is the label. So uh, in supervised machine learning, we have the data along with its label, and we give that to the computer, and the computer is able to study the data and its probable probable label, and then from there I can be able to make future predictions. So we have data, basically a question and an answer. We give to the computer is able to study the question and its corresponding answer, so it can be able to answer future questions. That's basically what supervised machine learning is. So supervised machine learning is very into two main broad branches. It's very into regression analysis, which we'll look at in this tutorial. We will look at linear regression. Okay, it also has another broad category called classification, because classification is all about trying to classify two things. For example, if you go you show the computer, maybe you show a picture of a cat to the computer can be able to tell, okay, this is a cat. And if you show a picture of a dog, you're able to tell a dog. So the computer can be able to classify the difference between a dog and a cat. So that's called classification, right? So it's going to classify two things into two or more categories. So this can be a dog, this can be a cat, right? So that's two different categories. And for classification, we have two main branches of classification. We have multi-class classification and binary classification, and we'll look at all of that in the upcoming videos. So we have different algorithms such as logistic regression, random forest, k nearest neighbors, decision tree, and we'll look at all this. Okay. So for regression, we've looked at the linear regression model, or for random forest regressor model. Okay. So let's move on to unsupervised machine learning. So unsupervised machine learning, unlike supervised machine learning, whereby we give it a question along with its corresponding answer. In unsupervised machine learning, we just give it a bunch of questions without the answer. So the computer will be able to study data itself and be able to come up with its own different categories or classifications. So for example, let's say that we take a picture we take an apple, and we measure the dimensions of the apple, the color of the apple, and we collect all that record into a data set, right? So we have that data set, and also take data set about avocados, right? So we collect data about avocados, like what's the dimension of avocado, what color is an avocado, all that information, and put all of that into a data set, and we use that to train the machine learning. So we give that to a computer. The computer, you don't need to tell the computer which record is actually an apple or which record is actually avocado. So we just give the computer the records of the features of an apple and avocado, without telling the machine, without telling the computer which of the record belongs to an apple class, or which of the record belongs to an avocado class. So the machine will be able to study the stuff. You have computer machine learning algorithms that will be able to study the data and be able to classify. Okay, maybe apples have a smaller dimension compared to avocados. Okay, so this maybe the computer can make the decision basing on the different diameters. Okay, this is an apple and this is an avocado. Or make decision basing on the class. Okay, this belongs to avocado. This belongs to a mango, because sorry, an apple, because the classes or the colors are different or the dimensions are different. So the computer will be able to learn on its own without us having to actually go ahead and tell it which of the records belong to which class, whether avocado or an apple. We don't have to tell it will figure that itself. So that is called unsupervised machine learning. And we have two main branches of unsupervised machine learning. We have clustering and dimensionality reduction. So clustering, we have models like k-means, k-mods, and for dimensionality reduction, you have things like PCA, principal component analysis. You also have the GDA, general discriminator analysis and stuff like that. Okay, that's unsupervised machine learning, whereby you just provide a computer with a bunch of features without the attached labels. Okay, so you just provide the data without its attached label, so the computer will be able to figure out the labels on its own. Okay, good. So also we also have the last one, which is called reinforcement learning. So reinforcement learning is actually very intuitive to understand. So for example, think of it like you have a dog at home, right? And you want to give this dog or a puppy. Let's say that you want to give the puppy a name. So how do you give the puppy a name? So let's say that every time before you give a treat to the puppy, you call a certain name. So let's say that you want to name your puppy Skippy, right? So before you give the puppy a treat, you just say Skippy, and if the puppy responds to the name Skippy, you give it a treat, right? And if it doesn't respond to the name Skippy, you don't give it a treat. So every time if you do that day after day after day, eventually the puppy will start responding to the name Skippy, right? So because it knows that if I respond to the name Skippy, I'm getting a treat. If I don't respond to it, I'm not going to get a treat. So that's a reward, right? So you're giving the puppy a reward for doing what you want it to do, basically responding to the name Skippy, right? So that's a reward. And if it does not respond to the name Skippy, you don't give it a reward. You give it a negative reward, which is not getting a treat, right? So eventually the dog will start responding to the name Skippy, because he knows every time you say Skippy, he's probably gonna get a treat, right? So that's basically what reinforcement learning is, and that's the same concept we apply to machine learning as well. So we give the computer a good reward whenever it does something that we want, or we give it a negative reward whenever it does something that we don't want. So okay, you might be confused. Okay, how do we give the computer a reward? A reward could maybe like this: adding a number, adding a number, incrementing a number, or the negative reward could be decrementing a number, right? So that's basically what the reward can be in terms of computers. So I also have a whole course on I made a whole video on reinforcement learning, so you can check that out on my YouTube channel. So and reinforcement learning, we have different algorithms that can be used, such as Q learning, SARA, temporary difference learning. I also have a whole tutorial on reinforcement learning on covering Q learning, so you can check that up on my channel. Okay, you can check the channel's main page. If I remember, I can leave a link in the description of the video. So now we have looked at the three main branches of machine learning, and you have understand a little bit of each branch, right? So that this is more bigger than this, but this is just I give you an overview. Okay, so once you have looked at that, let's look at regression analysis, which you're going to be covering in this video. So let's say that you have a variable x and y. So regression analysis is a reliable method of identifying which variables have impact on a topic of interest. So for example, you want to try to predict the price of a car, right? So which the car can have different features. Like it can have maybe the size of the engine, how many doors the car has, where the engine is located, whether at the rear or at the front, and all of that. So we can use all of that to train a machine learning model, so the machine learning model can understand, okay, which of the features affects the price the most. Is it the engine that has most effect on the price, or is it the number of doors of the car that has most impact on the price of the car, or is it the position of the engine? Is it the rear engine? Cars are more expensive than the four engine cars. So that's basically regression analysis. You're trying to understand the relation between two variables. In this case, you're trying to understand the relation between, let's just use one variable in this case. Let's say you're trying to understand the relation between the size of the engine and the price of the car, right? So that's basically, you can use regression analysis to answer that question, because regression analysis just aims at trying to understand the relation between the engine of the car and the price of the car, two variables, right? So you can have more than one factor which can determine. So we determine basically which factors matter the most, which factors can be ignored or get rid of, basically. Okay, so let's go on and look at regression analysis. Let's look at regression, basically. So regression, linear regression in this case. So let's say that in high school, you probably come across these maps like this, right? Like graphs like this, whereby you draw maybe x against y on a graph paper, right? So we have something very similar. This is very similar to what linear regression actually is. So actually, this is actually linear regression. So let's say that your x is the price of the size of the engine of the car, and y is what you're trying to predict, basically the price of the car. So you collect data from different existing cars, right? So you take the car, the size of the engine, and then you map it to its price. So at the end of the day, you have a graph similar to this, right? So let's say that a person also gives you a size of an engine. Let's say the engine is around maybe here. The engine size is around here. So they tell you to predict the price of the car. What you probably do is we did this in high school. I don't know which education system you guys are in, but if the education system that we went through, we did this actually in high school. So maybe they give you a price of the car, so you go, sorry, the engine, the size of the engine. So you go and trace it from here and trace the y-axis to the linear line, and then you draw it through this way. So you're able to predict the price of the car. So whatever that comes here, whatever number you get from here is the price of the car. Something very similar to this, right? I think maybe also you also did this in high school or primary school. I don't know. So that's basically what linear regression is. So just using we call this one the dependent variable. Sorry, the independent variable, and we call this one the dependent variable. So dependent variable is the factor you are trying to predict. In this case, the price of the car, y, and independent variable is the factor you are using to make the prediction. In this case, the size of the engine, x. So basically, the y is the price which you're trying to predict. So it's the dependent variable, and this x is what you're trying to use to predict the price of the car, which is the size of the engine. So it's an independent variable. So that's basically what linear regression is. So we have two types of linear regression in machine learning. We have a single variate linear regression. Also have multivariate linear regression. So now that we've looked at the different types of linear regression, let's jump in doing a simple project. So in this project, you're going to go ahead and you're going to try to use linear regression to predict the size of the car. So you're going to be using machine learning for this. Again, you don't have to install anything on your machine to get started with this, because you're going to be using something that Google provides us for free. You can use just in your web browser. So let me just go and switch to my web browser. So instead of my web browser, I'm just going to open a new window, and I'm going to search for Colab. So Colab, and just simply search for Colab and press enter. So once you press enter this, you just click on the first link, collab.research.google.com, and click on that first link. So once you click on that first link, I'm going to go ahead and generate a new notebook. Okay, so this is just some notebook that I already have. So I'm going to go ahead and generate a new notebook. So I'm going to click new, and it's going to open up a new notebook. So this is just we call them notebook in machine learning. This is just something that you can use to write your different machine learning code inside. Okay, so just create a new notebook, and once you have a new notebook created, again, you also must have a Google account to be able to do this. Okay, so once you have that done, I can just go here and change the name of the notebook. So just say car price tutorial. So let me just call it car price tutorial. So call it anything that you want, you want to call it, so feel free. So once we have that done, good, we have the car price tutorial done. So one thing I also want to go ahead and download, I want you to go ahead and download this file right here. So I'm going to share this link. The link is going to be in the description of the video. So I'm going to make this share the link. So let me just actually copy that, and copy that link, and I'm going to share that link with you. So once you have that link open, just simply click on the download button to download this file right here. So this file is simply the file we're going to be containing the data that we're going to be using to train our machine learning model to be able to predict the price of the car. So basically, it has the name of the car, the fuel type of the car, whether it's gas, diesel, or petrol. It has different factors, and then finally we have a column that tells us the price of the car. So using all these features, you're able to predict the price of the car. So using like the highway MPG, using the car weight, the car height, the car width, you are going to be able to predict the price of the car. So that's basically what you are going to go ahead and do. So that's a lot of data. It's about let me just see. That's a lot of data. In machine learning model, the more data in machine learning, the more data you have, the better your model is going to be. So it's just 206 lines. That's actually few. In real machine learning, sometimes you have more data than just 206 rows of data. Okay, so once we have that done, let's go ahead and actually open up this file in here. So let me just go ahead and create a text field. So I'm just going to click, go up here and just click on text. I'm going to go ahead and click on text here. So I'm going to just type in some text. I'm going to use Markdown. And if you know Markdown is, just don't worry, just type after me. So just type in double, triple hashtag, and just simply say loading data. Okay, so if I do that, I can simply go ahead and simply press enter. So make sure that you have the data downloaded on your machine. So once you have the data downloaded, you're going to go ahead and import a couple of things. You're going to use some libraries, and what are these libraries? These are just some libraries that is written that you can use without having to write the code from scratch ourselves. So I want to go ahead and simply load up this file that you have downloaded. So I assume that you already downloaded this file on your local machine. So once you have this downloaded, you're going to load it into this Jupyter notebook. Into this Colab notebook. Okay. So what I'm going to go ahead and say from Google .colab import files, just like that. And once you have that import, I'm going to say uploaded. I'm going to say uploaded. You can say upload underscore file is going to be equals to, I'm going to say files upload. So I'm going to say file upload, just like that, and call. Once you have that done, you can go ahead and simply press on this play button to run this cell. Okay, so just press on this play button to run this cell, or you can go up here and just say you can say run. You run cells from here. You can say run all. That's going to run all the cells, but avoid using run all, and I'll explain to you why. Okay, so what you want to do is just press on this play button, or you can press shift and enter on your keyboard. So just press shift and enter on your keyboard. Either ways is going to run the file. It's going to run this cell. So it's going to run the code only present in this cell and not any other cell. So it's going to run the code only within this cell. So you can see we have another cell down here, and it's going to run the code only in this cell. Okay. So okay, I got the spelling wrong. This has collab without an L. So sorry for that. So once I have that done, I'm just going ahead and pressing shift. So make sure you select this cell. Make sure your cursor is within this cell, and simply press this play button right here. You can press shift and enter on your keyboard. So I'm going to press shift and enter, and it's going to prompt me to select the file that we just downloaded. So you're going to say choose a file. So click on choose a file, and then go ahead and choose the file. So I have the file right here, which is right here. Let me see, car price, this one, and then simply open that up. So once I open it up, you can see car price dataset.csv. So once I have that opened up, I can go ahead and use this file right here. So I can just go ahead and inside of this cell, I can just say I want to print up uploaded. So let me just say uploaded file, and I can press shift and enter to run it. And let's see what we have. So we have uploaded the file, and these are all the content of that file, but we don't want it in this format. So what you're going to go ahead and do is really read this file into a CSV, what we call a CSV file. So let me just go ahead and let me just create another text cell right here, and I'm going to use the 3 exclamations right here just for markdown, and I'm going to simply write data analysis. We're going to analyze our car data before making a machine learning model. Okay, so once we have that done, I'm going to go ahead and import a couple of things. So I'm going to go ahead and import the following. So I'm going to say import import pandas as a PD. I'm also going to go ahead and import IO, sorry, and then press enter, which is just, sorry, shift and enter on your keyboard, or just use this play button. Okay, so once I have that done, I'm going to create another code cell, and in here I'm going to go ahead and type in df, which is called, this is just short for data frame. So data, what when you read these things into a CSV when you read this data from a CSV file, we're going to put it instead of something called a data frame, basically a pandas data frame. So if you're not pandas is, don't worry, I have a whole tutorial on pandas on my channel. You can check this out, but in this case you don't have to check it out. You just watch, just follow along. I'll explain everything. Again, if later on you are interested in pandas, you can check out my channel. I have a whole tutorial on pandas up there. So once I have that, I'm going to say pd.read, because we imported pandas as pd. Okay, so read underscore csv, rather, sorry, csv csv, and then simply pass in the name of the file that you want to read. In this case, you're going to say io.byte io. Okay, and then simply pass in the name of the file that you want to read, it's called uploaded file, and you want to simply say you want to get the name of the file. So if you look closely inside of the, just scroll down here. So if I just scroll down here and try to bring the cursor of this up, completely up right here, and let me just scroll up right here. Let's see, bring this completely up. Yeah, so if I scroll up here, you can see we have the name. This should display the name of the file that we just uploaded. If it doesn't display the name of the file, fine, that's still fine. We can simply get the name of the file ourselves. Basically, the name of the file is just simply call it the name of the file that you just uploaded. So it's going to be called, I called it car. It's going to be in strings rather. So you say car price underscore data set dot csv, just like that. And this is the name of the file that you just uploaded. Okay, so this is the data car price, not prints. Okay, so once I have that done, I can simply go ahead and simply run that file. So let's press shift and enter to run it. So we have an attribute called, I have an error right here. So let me check what my error is. So this basically import io, and then io.byte. This is bytes code. Okay, so bytes.io. So mine is bad. So this is bytes.io, and simply run that. Okay. So once I run it, we didn't get any error. So everything works fine. So if I go ahead and write, try to get type in df and simply run this cell, it's going to show me what we call a data frame in machine learning. So you can see this is the same data that we have inside of our file, but now loaded inside of a CSV file within pandas. Okay, so sorry, loaded within a pandas data frame. That's basically it. So now this is called a data frame in pandas, or a pandas data frame. So you can see all the columns from this file, this CSV file, are now loaded inside of this data frame. That's why we call this a df, which is this data frame. So you can say df.head, which is going to return to you the first 5 columns, the first 5 rows of that CSV file. Basically, you can see now we have only just 5 rows, because that's from 0, it goes until 4. That's 5 rows. And you can see that you have a total of 26 different columns. And you see all these 26 columns are just talking about the features of that car. And then finally, we are going to use those features to try to predict the price of the car, which is this price right here. Good. So once we have that done, you can also do dot tail. That's going to show you the last 5 columns from the bottom of the CSV file. So this is going to show around from 206 upwards. So yeah, 206 upwards. So you can see that right here. So mostly just people doing head. Okay, so I'm just going to do head and simply run that cell, shift and enter on your keyboard. Okay, so once I have that done, we are good to go. Now we have loaded our data. We can also check the shape of the data. So if I do df.shape, when I run that, so this is going to turn to the number of rows and number of columns that we have. So this number of rows that we have, right, and number of columns that we have. So what are rows and columns? We might be confused. Okay, so let's scroll up here. So if I scroll up here, you can see these are called rows. Sorry, these are called columns rather. So if the ones going down are called columns. So fuel type is a column name, and then aspiration is a column name. The door number, the number of doors that the car has, is a column name. So you can see these are rows right here. The one, this 0 is a row, 1 row, 2 row, like that. So rows goes from left to right, while columns goes from top to bottom. So that's the difference between a column and a row. So I hope you understand. So we have 205 rows and 26 columns. So 205 rows going from top to bottom, and 26 going from left to right. Right. Okay. So that's basically what the shape tells us. So if I do a df.describe, describe and then run that. So if I call that function on that data frame, it turns to us another data frame consisting of a statistical summary. Again, I'm not going to go ahead and explain for you the statistics in the video, so I'm not going to tell you what standard deviation means, what is the mean, what's the 25 percentile, 50 percentile, 25 percentile marks. I'm not going to explain all of that to you, but I have a whole series on my introduction to statistics on my channel, so you can check that out. Again, I'm going to explain everything to you, so you don't need actually that video. You don't actually need to follow along with that video to understand this. But it's always a good practice to understand the statistics behind machine learning. So always go back and check out that video. We did statistics with machine learning with pandas with Python. So you can check out that video if you are new to or you want to brush up on your statistics a bit. Okay. So basically we have the mark. We can check the marks, and the max price is around 45,400. You check the mean price, which is right here. Mean, this one right here. The mean is around this one right here, the mean price. So you can check the 25th percentile, the 50th percentile, the 75th percentile, the mean. So there was an average price of the car. On average, the price of the car is around 13,000. 13,000. Okay. So I don't know which currency they use there. So I don't want to say the currency. Maybe it's in dollars or Indian rupees or something else. I don't know. Okay. Okay. So once you have the summary done, you can also get the DF information. So df.info, just like that, info, and run that. So if I run this, it's going to return to me the info about the different columns that we have. So this is going to show me all the different columns. So once I run that, it's going to return to me the different columns of the different columns along with the data type. So you can see we have the car ID, and it's of int 64, means an integer of 64 bytes. Okay, we have symboling and int 64. We have object string type. So if I look at this fuel type, its data type is at object, and if I check object, if I go ahead and fuel type, you can see these are just strings, right? So yeah, that's basically it. You can read more about the different data types again. If you want to check more about pandas, you can check out my video on pandas where I explain all this. Okay, so I'm not going to go in depth about this. You can just read out on your own. So you can even see the size, memory that has been used by this data set and all that information. Good. So once we have that done, I'm going to go ahead and you're going to go ahead and do some data cleaning and preparing the data, because sometimes if you have data, you might have missing columns or the data not being in the good format. So you need to first go ahead and clean the data and then prepare the data before you can train a machine learning model. So let's go ahead and do the data cleaning and the data preparation. So this is called data cleaning and data preparation. And I have a whole series on data cleaning and data preparation in machine learning, so you can go ahead and actually check out that video as well if you are interested. Okay, so once we have it done, let's go ahead, let's keep some comment right here. Let's say data cleaning and preparation, just like that, and run that. So we're going to go ahead and clean our data from here. So we're going to say car underscore name underscore detail. What I want to go ahead and do and get the name of the car and simply split it up, because I want to have the car name on its own and the label of the car separate information. So if I go ahead and let me just print a column right here. So if I go ahead and create a code block, a code cell, and if I do df and I try to get the car info, so I can simply do it by saying dot. Let me show you the different ways of doing it. You can dot car name, and if you run that, it's going to return to the name of the car. So if you can see, these are just some columns that it returns. So I can see the first we have this column right here, and it's called Alpha Romero, and then Gui Gulia. I don't know that's what name is that. But you can see the name of the car is Alfa Romeo, and then this is probably the company. So let me just look at something more familiar. Okay, I'm familiar with Volvo, so you can see Volvo is the name of the company, and then this is the name of the car. Okay, so you can see Audi. Audi is the name of the company, and then this is probably the name of the car. So what we want to do is I want to split the name of the car into a different column and name of the company into the brand of the car into another column. So what I'm going to do, I'm going to split this information based on space, right? I'm going to split the information based on space. So I don't know if you guys remember how to split the information based on space, but you can just simply do something like this. Let's say, um, let me just have some random text. I can say hello world, and then I can just say dot split, and I can say split on space, and let's just run that code and let's see what we get. So you can see now it's going to return to me two things: a list, right? One having hello, and then the other one having the element being world, because it's going to split based on space. So we're going to take all this part, and when you see space, this will be one element, and then start taking after the space again. So that's how you can split information. So that's what I want to go ahead and do here. Just split the information based on space. Let me just go ahead and, now that you've understood this, let me just go ahead and delete this cell. So delete the cell. That's how you can delete the cell. I'm also going to delete this. Okay. So I'm going to say car detail, and it's going to be equals to, I'm going to say df. I'm going to get the name. You can also say you can also use the square. You can also use this notation to get the car name. So you can say car name just like that, or you can use the dot, which the dot notation which I showed you earlier on. So you can say dot apply, and say you're going to say lambda. Lambda, because you want to do this to all the other functions, which I cover lambda and all this in my introduction to Python 3. So if you want to check out the video, you can check out the video on, or the course on introduction to programming with Python series, where we went over all these concepts. Okay, so once I have this done, I'm just going to go ahead and I can go ahead and print. Let me just call this car. Let me just call it car. Okay, and I'm going to copy that and move it in here. So paste it there. No, sorry. Just copy that and then paste it in here. So once I have that, I can run it and let's see what we get. So you can see now we have split the name. This is the name of the brand, and then it's actually the name of the car, right? So now what I want to go ahead and do is actually create a new column and then insert the data into that column. Okay, so let me just comment this out for now. And to comment out, you can just press a control and the forward slash or the question mark keyboard, question mark on your keyboard. Okay. So once I have that, I'm going to go ahead and create a new column. Okay, there's going to be a comment. So once I'm going to say car underscore brand is going to be equals to car underscore name, which is what we have. Car name underscore detail dot we're going to say apply. So we're going to say apply, and we're going to pass in a lambda. So let me just get that spelling. Apply, and you're going to pass in a lambda. Lambda, going to take in x, and you're going to say x. You're going to go ahead and simply get the first index, which is going to be the name of the car. Okay, so we're going to go ahead and copy this and paste it again. So now this is going to be the name of the car, right? And the first one is the name of the brand, and it's going to be the name of the car. So it's going to be at index 1. We're going to also keep some logic in here. We're going to simply say if the length of x is going to be equals to 2. That's what I'm going to do, because I checked the data earlier on and it has some parts where the name of the car is not separate. The name of the car is not specified. So I'm going to say no, the name of the car is not specified. Else you're going to have this right here. Okay, so that's good, and we're going to go ahead, and these are the ternary statements. Okay, so you can actually check out my video introduction to Python where we went over all this. Okay, so I'm going to go ahead and print the car underscore brand, and I'm going to simply copy that code and paste it here, and then simply name of the I'm going to now say car underscore name, and then simply run that code. So you can see I have the name of the car and also the brand information. So good. So I'm going to comment that out. Okay, so once I have that deleted, I just deleted it, so I'm just continue writing the code. So just going to say df.insert. So we're going to insert a column at index 3. We're going to insert a column at index 3. Okay, and we're going to simply say the brand is just going to be let's call this column actually brand. So brand, and which column do you want to, which data do you want to insert into? We're going to insert the car underscore brand. Okay, information, and I'm also going to go ahead and say df, and I'm going to say car name. So we're going to change the existing car name to the one that we just generated ourselves. So I'm going to say car name is going to be equals to car underscore name, and then from there I can just go df.head to check out that information, and then simply I can go ahead and run that cell. Okay, now you see, now that you run the cell, we can see that we have added another column called brand, which it contains the name of the brand, and then finally we have the name of the car itself. So you can see audio is a car brand, and you can see there we have the name of the car. So good, you can see the place we have no name because the car name is landed. The car name doesn't exist, that's why you have no name there. So it's fine. So once we have this done, you're going to go ahead and do some check some brand. Let's check the unique brands that this car has. So just you're just analyzing the data, trying to see what data you have and all that. So we're going to say df dot brand underscore sorry, the brand dot, you're going to check the unique. So you're going to say df, and you're getting the car brand column, and you're checking the unique how many unique values we have in there. So how many unique brands we have. So you can see we have this amount of unique brands. We have Audi, we have BMW, we have Chevrolet. We have a Hyundai, we have Isuzu, we have Jaguar, we have Mazda, and we also have Mazda. So I think this is probably a typo. So these are probably the same name. So you have to actually fix that error. That's a pointer to the importance of analyzing your data before training a machine learning model. So you can see right now, this is actually needs to be Mazda. So you need to change that. We have I don't know, big, and we have Mercury, we have Mitsubishi, we have Nissan, and also we have Nissan again. The one is a capital N, one is a small letter N. So you need to actually make normalize this. Okay, we have Peugeot, we have Porsche, and you can see the spelling of Porsche is different in these two instances. So we need to fix that error as well. We have Volkswagen, and the error is different. So you can see the spelling is different. So we need to fix that as well. And also this Volkswagen, this is also Volkswagen, right? VW, and also have Volvo and all that. So you can have also Subaru, Toyota, and also Toyota. We need to fix the typo because this is actually just Toyota, but the person added an extra U. So we need to actually do the data cleaning on that. So you can see the importance of checking your data before cleaning a machine learning model, before training a model. So you can say car name dot. Let's also check the uniqueness of the car names, and let's see how many unique car names we have. So this is number of unique car names we have. We have this amount of cars. Okay, so you can see RX or this much RX3. Okay, so you can see all that kind of information. So now I don't see anything wrong with the car name, so actually fine. So what you need to do is actually fix this brand names. Okay, so let's go ahead and actually fix the brand name. And to fix the brand name, you're just going to go ahead and replace a couple of things. So we're going to simply say df dot brand dot replace. We're going to say replace, and we're going to replace a couple of columns. We're going to replace we're going to replace Volkswagen, which is the wrong type spelling. We're going to replace this with actual good spelling. So I'm going to copy this. I'm going to paste it in here. So paste it in here, and I'm going to go ahead and actually paste in the correct one, which is Volkswagen. So I hope that's the correct spelling. So I'm going to paste that in there, and you're going to replace. You're going to say in place equals to true, just to avoid reassigning. Again, if you don't know the base of pandas, you can check out my video on pandas. Okay, so I'm not going to explain all these integrate details. Okay, so now just to make sure we speed this thing up a bit, let me just open the notebook that I already have that has some code, and let me just copy and paste some code in here. Okay, so I'm just going to go ahead and search for collab, and I'm going to make the link to this available. So I'm going to open collab, and I'm going to open the notebook that I already have. So car price prediction, yeah. And once I have this open up, I want to go ahead and get some code that we can just use here to save a bit of time. So I have all this notebook already prepared with detailed information, so you can check that. I'm going to share the link with you guys. Okay, so this way we're ready so far. We're checking the name of the unique column. So changing the name of the column, so fixing that. So I'm going to go ahead and simply copy this code and paste it in here. Okay, okay, so I'm just delete this column for now and just paste it in here. Good. So once you have that, you can simply go ahead and run the code again. So it's going to replace all the mistyped columns with the correct one. So we're going to replace Nissan with Nissan, this Maxda with Mazda. Okay, this Porsche spelling, wrong spelling with the actual Porsche spelling. Toyota with a U with proper spelling of Toyota. VW with Volkswagen, and all of that. So basically that's what we have, and we check again the brand new index. We can see everything is as should be. So once we have that cleaned up, let's check for duplicates in our data. So I'm going to make another cell here. I'm just going to check, say, check for duplicates. Again, these are just some comments that I'm using. So if you want to write this, is fine. You don't have to write it. Okay. So once I have this done, I'm just going to go and say df dot duplicate duplicated, and then simply check the sum of the duplicated columns, and then run that. Let's see if you have any duplicated df dot duplicated. Okay, let me just let me fix that. Okay, so if I run the cell again, you can see we have zero. We don't have any duplicates duplicate columns in our data. So good. Once you have that done, we can go to go. So let's check for if you have any null values. So let's just say check for null values. Check for null values. So null values, basically sometimes you have data, and some data, some cells might not have data. So that we call it null values in machine learning. So basically, you're just checking for any missing values, and you're going to go ahead and probably delete them, or there are different ways of handling them. Again, you can check out my video on data preparation and cleaning in machine learning, where we explain all of these concepts. Okay, so if I run this again, we can see we don't have any missing values in any of the columns, so we are good to go. So you can see all of them as zero. So if you have anything like one means you have any missing value, and you need to go ahead and delete it, and I explain all of that in my video on data cleaning with machine for machine learning models. Okay, so once we have that out of the way, let's go ahead and do some bit of data visualization. Data visualization is just where we visualize the data to understand the data even more, just like performing data analysis. Okay, because before you can train a machine learning model, you need to understand what form is the data, which machine learning model should you use. Okay, so if you go more into machine learning, you understand this concept. But for now, we're just going to go ahead and use linear regression, because I've already done all this work for you, so don't have to worry about it. Okay, so what I have to do, I have to import a couple of things. I'm going to import matplotlib dot pyplot as plt, just like that. I also want to go ahead and import one more thing. I want to import seaborn. So I want to import seaborn as SNS. Okay, and then run that. So I have videos on seaborn on my YouTube channel if you want to check that out. Or we did the introduction to data visualization in Python, where we visualize different data sets. Okay, so once we have that done, I want to go ahead and plot a data looking at the price of the car, and then the price distribution of the car basically. Okay, so I want to take the price distribution of the car. So I'm going to simply go ahead and grab this code from here, so I don't have to waste watch me type this out. So I'm going to grab the code from here, and I'm going to go ahead and paste it right here. So paste the code in there and run the cell. Okay, so you can pause the video and type it out, or you can actually get the code from the link in the description. So this is basically the code, and it shows us the data distribution. Okay, so basically we just created a figure, and then the figure, we're going to give the figure a title of price distribution, and you're going to say SNS dot distribution plot, which says SNS this plot, that is used to draw a distribution plot. So it is drawing the distribution plot of the price column. So going df dot price, and you're simply doing plt.show and plt.tat layout just to format it properly. So you can see we have the plt.show just shows the graph, and plt.tat layout just does some proper layouting. Okay, so now you can see the price distribution of the car, of the different cars that we have. So you can see this is a price right here, and the price and the distribution. So you can see this is actually a skewed distribution, and we covered all of this in my introduction to statistical analysis in Python. So you can see this is skewed data. So if you want to understand all these terminologies I'm using, skewed data, positively skewed, negatively skewed, you can check out that video. Again, you don't have to check out that video to follow along. I'm going to explain everything to you. So I'm just saying the data is skewed because you can find these are called the tails of the tails of this line is pulled further towards the right than the left, right? So you can see the data is more pulled towards the right, and that's called a positively skew, or a right skew data. So you can see it's pulled towards the right more than the left. So this is a positively skewed data, and this tells us that the most we have most expensive car around 50,000. Sorry, 500. Yeah, 50,000. Yeah, that's 50,000. So that's the more about the most expensive car, and you can see all of that. And the list, this I call the mean. The mode is the number of the highest value. So you can see this one right here. Most cars around 10,000. Okay, I don't know which currency is this, but most cars around 10,000. Okay, okay, good. So once you have looked at that, I also want to go ahead and make some inferences from this graph, because once you draw the graph, it's just for you to make inferences to understand the data better. So the first thing you can say that is this: the data is positively skewed, right? I had to explain to you what positively skewed means. So I can just actually write the inferences at the bottom. You can say the first one, I'm going to say 1, and the data is positively skewed. Okay, okay, so I have the mic in front of me, that's why my typing is a bit slow. So positively skewed, and we can also say 2, and 2 is going to be the mean is more than the mode. Yeah, that explains what we mean by the data is positively skewed. So we can just run that. Okay, so one thing that you can learn from this graph is the data is positively skewed in terms of the price distribution. Okay, now let's look at describe the price. You can say df dot price. You're going to get the price column. So dot price, you can just say dot describe, just like that, and then run that. So we're going to give us the price description. You're going to give the mean price, which is around 5,000, and the maximum price around 45,000, 400. Yeah, and you can see the standard deviations right here. So you can see we have the 25th percentile. Basically, sorry, I mean the standard deviation is this one right here. You also have the percentile, the 25th percentile. So but most of the 75% of our data of the cars that we have are below this amount right here, and 75%, 50% are this value right here or above, and then 75 sorry, this 50% of the cars are above this price or above, and 75% of these cars are this or above. So that's basically what it means to understand. Again, I covered all this on my introduction to data analysis with Python, so you can check that out. Okay. Okay. So once we have that done, we can go ahead and we can take the different data types that we have. So we can do df.d types. It's going to turn to the different data types we have. I think we look at this when you check the info part, and I explain to you what these data types are and what they mean, right? So that's basically the same thing we have right here. So let's move on and let's get all the categorical columns. So in machine learning, we have something called categorical columns. Again, anything that is not a number, basically it's a categorical column. That's basically it. So you can think of it, this float is a number column, integers are all numbers, but objects are not numbers, right? They're textual data, so they're called categorical, right? So they're category, like for example, if you talk about the number of cars, the number of doors that a car has, right? A car can have 2 doors or 4 doors, right? That's category. Either belong to this category or the other category. You're not in between, right? So that's basically we call categorical columns. So let's see how we can get the categorical columns from our data. So let me just go ahead and grab the code from here so to we save time and not waste time on this. So I'm just going to go ahead and try to get the column for that. So I'm going to get it right here. So we get it from right here. So this is the code for it right here. So I'm just going to go ahead and grab this code right here and just copy it, and I can go in here and simply paste it inside of this cell, code cell, and run a code. So you can see now it's going to return to us like different categorical columns of our data, and to get the categorical columns, we just say df.select type d type, and we say include an object, and I told you object is for categorical column. Right, and you convert that object into to a list data type, and it is printing out, which we have this a list object right here. So you can see car is of category, like the name of the car is a categorical like string. For the name of the brand is category, like Toyota brand, Suzuki, Subaru, all that. And you have the fuel type, gas, diesel, petroleum. Okay, and you have the aspiration, you have the door number, 2 doors, 3 doors, 4 doors. Okay, that's category. The body type category, the number of wheelbase category, the engine location at the rear or at the back, the engine type. Okay, we have the number of cylinders, like a V8. A V8 engine has 8 cylinders, V12, and all that. So we have also the fuel system and everything. So you can see all the different categorical columns that we have. Good. So once we have that, I want to go ahead and plot the graph that to visualize these categorical columns. So let me just go ahead and grab the code for that, because I don't want you guys to waste or watch me type all this out. So I'm just going to go ahead and grab the code from here. Okay, and I have links to all this code in case you guys want to read more. I have all the links and other things specified right here. So I'm just go ahead and grab all this and then simply copy them and paste it right here. So we're going to visualize the different categorical columns that we have. Again, I have links to different documents that you can look out, and documentation on read more about plotting graphs in case you're interested. Again, I have a video on all this on my YouTube channel, so you can check that out. So if I run that, it's going to visualize the graph that we have. So you can see we have the graph being visualized right here. Okay. So we can see the brand, we can see the most common brand is the Toyota brand, which has the most cars are Toyota brand. In our data set, we have the fuel type, we have the gas and diesel. Most cars are gas fuel type. And aspiration, we have the STD aspiration or the turbo aspiration. The most common one is the STD. And then we also have the door numbers, like 2 doors or 4 doors. And most of the cars that we have in our data set are actually 4 doors. And then you look at the number of body type. We have the sedan, the convertible, the hatchback, the wagon, the hard top. So you can see that the sedan vehicles actually the most that we have, and the list is probably a hard top and convertibles. Okay, and then hatchbacks actually the hatchback actually the second, and then finally we have wagons. And if it comes to if you come to aspiration, we can see that we have the STD is the most aspiration, and then you have turbo. And then finally, we come to the number of doors. We have the 4 doors and 2 doors, and then the number of four the cars with 4 doors leading. Most of our cars that we sell actually, or for the data set, actually 4 doors. And we got the car body. We have sedan, the convertible, the wagon, the hatchback, and also the hardtop. So the most common one is actually the sedan body type, and the sedans. Okay, So sedan are the most, and then finally we have the wagon. Sorry, actually, you have the hatchback, and then finally the wagon, and then the hardtop and the convertible. I think the list is the convertible, the type, body type. And look at look, also have the drive wheel, and we have the rear wheel drive, the forward wheel drive, and then the four wheel drive, right? So I don't know if you guys know much about cars, but I don't want to talk about all this. Four wheel drive means all the wheels are like spinning. Two wheel drive, the rear wheel drive means that just the back wheels we are spinning, like when the car is moving, and then the four wheel drive is just the forward wheels are spinning, the back ones don't spin. Okay, like the engine is that they are powering the only the front wheels, right? You also have and most cars are probably powered by the forward wheels, as you can see here, forward wheel drive. We also have the engine location. We have the engine being at the back or at the front, so you can see all that information right here. So good. So once we have there, you can see the engine location. You can see those the engine type, like OHC is the most common engine type, and the least one being the DOHC being the least engine type. Okay, so once we have that, you can also check out the cylinder number. So you can see four cylinders actually leading. The four cylinder engine is actually the most common one, and the least ones I think is the V12, the 12 cylinder engines are actually the least common ones, and all that information. And you also look at the fuel systems. We have the MPFI is the most common fuel system, and the least one being I think MFI or SPFI. So yeah, that's the information about the fuel system. Again, as a data scientist or working as machine learning, sometimes you don't understand all this information. So you have to go and Google and read more about what every of this information does. Okay. So let's just draw some inferences from that I draw from the data. So draw some conclusions from this data, because that's the whole point we are plotting this graph, right? To be able to understand the information. So the first, let me just keep here and saying, okay, I want this one to be a text field. So I'm going to say one, and the first one you're going to say, let me keep this in here. I'm going to say Toyota. So this is the inference that I draw from the data. So I'm just going to write to you some inference. Toyota is the most popular car brand. And if you look at the brand, you can see Toyota is the most popular car brand. So you can say Toyota is the most popular car brand. You can see right here. So you can just using this graph, you can write some inferences to help you to understand the information better. So you can say Toyota is the most common car brand in the data set, just like that. And you can write more inferences if you want. You can actually put in more that you can say sedan is the most common body type of the car, right? So sedan, and you can sedan uh, is the most common body type in the data set, just like that. So yeah, you can write more inferences that you want. But I'm just going to write two inferences because I don't want to waste your time. Basically, just by looking at this graph, you can make your own inferences. So let me just write for you at least for some aspiration. You can say some inference that I noted earlier on. So you can see gas fuel type are the most common one. You can see gas fuel are the most common one. Gas fuel is the most common one. Four doors vehicles are the most common one, right? So four wheel drive, the most common one. This one right here. You can also say the forward engine is the most common one, which is the engine location, right? So if you look at the engine location, the front engine location is the most common one, while the rear is more expensive. I think the rear is more expensive, like Bugattis and other stuff like that. The engine is at the rear, right? So I don't know. I'm not a car expert, so I can't really tell. And you also have number the four cylinders. Okay, so you can see all that information. The four cylinders are the most common one, and V8, V12 are the least. Okay, so you can see that we have also V8s, like some Land Cruisers are V8 and other stuff. Again, I don't want to go ahead and talk about the cars. Okay, about cars. Okay, so now that we have that, now let's take a look at some of the categorical features versus the price. So let's go ahead and grab that graph, and just go ahead and grab that graph information. And I'm just going to go ahead and copy it from here. And this is graph information you're going to use to visualize the common paste that in there. So I actually hit the wrong key. So I copy it again, and I'm going to paste it right here and then run the code. So it's going to give us the different categorical columns versus the price. So categorical features versus the price, right? So we have it right here. So it's a graph that we get after plotting that. Again, the code is going to be in the link to the notebook is going to be in the description. You can get all this graph. You don't have to waste a lot of time typing out that code. So you can see you have all that information right here. So you can see you have the brand. You can compare the brand with the price. So this is the brand and then the price. So you can see I think poachers are quite very expensive. You can see the poachers right here, and these are called box plots. Again, if you are not comfortable with statistics, I have a whole series on statistics where we went over box plots, all this, and how to plot all these graphs. So I'm not going to spend a lot of time explaining this graph. Basically, this is the mean value. This line at the bottom is the mean value, the mean, and this is the first quartile. And then the line in the middle is the second quartile or the median, and then finally the line up here is the maximum, and then finally any dots here is called an outlier. Okay, I don't want to go and explain any of those stuff to you, but you can go ahead and check out this on my YouTube page in case you want to understand. Okay, so if you, in case you want to understand more, you can actually just go ahead and read more into that. So you can see, I think poachers are the most expensive one, poachers from my point of view. This, and you can see also the fuel type. Okay, these are actually the same, but diesel fuels actually happen to be more slightly. The cheapest at a slightly higher price than this one, than the gas one. So that's it. And also for the turbo and the STD for the aspiration, the turbo happens to be a bit the cheapest you can get, a bit more expensive than the average STD one in terms of aspiration. And the door types, they're basically almost the same, and they're not much of a difference. Okay, and so we have the car body, and yeah, car body. I think the most one is a hatch top. You can find them. It has the maximum price is very high. The minimum price actually is not that cheap as well, so it's actually expensive. So let's see convertibles. I just happen to be the most expensive one. So the cheapest you can find is around like $12, 12,000 to $13,000, or let's say the currency is in dollars. Yeah, that's basically it. And you can also check the drive wheel. The drive wheel, not much of a difference, but yeah, there's a difference. Like the rear wheel drives are more expensive. Like sports cars are mostly rear wheel drives from Mike's, like Lamborghinis and that stuff. The engine is located at the back, right? So I don't know. I'm not a car person, so I can't really say. Let me know in the comment section what you guys think. Okay, so I've looked at that, and let's take a look at the engine location. So the rear engine ones happens to be very very expensive than the front engine cars, right? So that's what I was trying to explain to you, right? The back engine cars with the back engine located at the back are mostly sports cars, right? So they're more expensive than the average one. So you can see even the minimum price is starting from around 35,000. Okay, and the maximum is around this part right here. So good. That's basically it for the engine location. You can check the type of the engine. You can from there you can make research if you want to read more about this, the different engine types. And then you can make better conclusions from your data. Okay, so now I've looked at that, and now let's look at the number of cylinders. So you can see number of cylinders right here. The 12 cylinder is actually very expensive compared to all the other ones. But 8-cylinder engine you can find it has the maximum highest price. Okay, so at maximum price. And you can also check the fuel, the different fuel types and all that other stuff. Okay, so the fuel systems rather. So that's basically how you can analyze your data and be able to draw different conclusions from your data. So what conclusion can I draw from this? Let's say that you see Jaguar has the most highest average price. Okay, you can check from that is from this information where you can see Jaguar is quite very expensive. If you scroll up here, and take a look at the car prices. You can see Jaguar is quite very expensive. So you can see Jaguar right. Let's see, Jaguar is which Jaguar? Yeah, right here, and you can see has the most average price, very expensive for Jaguar. Yeah, so that's basically it. And yeah, so you can other influence gas engines have the highest average price. The rear engines are more expensive. The 12-cylinder engine have the highest average price. Also, the number of doors do not have much of difference. So the number of doors don't have much difference. So that's the inferences you can draw, and you can write all these inferences at the bottom, right? You can create a cell and then simply write these inferences right here. So you can just say one, and then you can write the inference. Let's say Jaguar as the most highest average price. So you can write all that information and all that inferences right here if you want to. Okay, so I've written all that information on the actual notebook that I have posted so you guys can get access to it. So I'm not going to write it right here. So once you look at that, let's go and look at the numeric data types the numeric data analysis, because I've been doing so far is for categorical data. So now let's look at some numeric data types, analysis for numeric data analysis. Okay, so I'm going to go ahead and simply say numeric data types analysis, just like that, and run that cell. So I'm just going to go in here and grab the code, and we will take a look at the code. So I'm just going to go down here, So before we get the numeric column, so I'm going to go ahead and get all the numeric columns. So select all of that, copy that, and simply paste it in here, and that's going to return to us the numeric column. So if I run it, I should get back a return of all the numeric column, and that should be the peak PMG, okay, the highway PMG, the price of the car, all that is in numeric, the ID of the car, the symboling, the wheelbase, the length of the car, the width of the car, the height of the car, the cab height, weight, all that is in numeric value. So that's the numeric values we have. So now let's try to analyze this numeric feature. So I have some information right here you guys can find. Okay, so bore ratio. I have did some research to explain to you the different car terminology. So city MPG is just the average score of car gets in the city condition and all of that. So highway MPG is just the average score on the highway condition. The engine size refers to the total number of cylinders in the engine. The you also have the power of the engine. Basically, we have the symboling, the bore ratio, bore stroke ratio of the cylinders and all that. So I'm not going to explain all this. These are just car information. As a data scientist, you need to understand this information to be able to come up with effective models. Okay, so I just did a research about all that, and I'm going to, again, you can find all that on the link is gonna be in the description to this notebook. Okay, so I'm going to simply copy this and paste it right here, so I can do some analysis on the numeric column. So I'm going to paste that right here. So what does this function do? This function just simply plots a scatter plot. Okay, so we're going to call this function on the numeric columns, and that's going to go ahead and plot for us a scatter plot of all the numeric features. So I'm just going to go ahead up here and just paste the video paste the code right there and then press enter. So it's going to draw for us a scatter plot of all the different features we have. So let's just give it some time, and it's going to draw a scatter plot that's going to look something like this. So you can see you're drawing each of the numeric features against the price. So you can see the price, and this is the highway MPM. So you can see the price of the car, and the highway is corresponding highway MPG. So yeah, so let me just scroll up here and let's try to analyze this a bit. Let's take a look at this data a bit. So you can see we have the car ID. We don't need the car ID. We don't really need it. So we don't care about the car ID. It doesn't affect the price of the car, right? So what you're interested in is other numeric columns, but not the car ID, right? So yeah, so once I have that, you can see the price of the car, and we have this one right here. So we can see symboling, the length. You can see this is actually the symboling versus the price. So we can check all that. So we can also read about the wheelbase versus the price. So it actually looks like a linear trend. So you can see like a linear line can fit in here. And you look at the car length and the price. So the longer the car, probably the more expensive it is, right? The more materials you need to make a longer car in terms of length. So you can see now that's a complete linear trend right there. So again, linear regression can fit through, yeah, if you draw a straight line through these data points. And you also have the car width, and the car width is the car width against the car price. So you can see also this a linear line can fit in here. So good. And you also have the car height. You can see this actually the car height and then its corresponding price and all that information. So this is basically it, analyzing that data. And you can see the engine size and the price. You can see a linear trend right there. The bigger the engine size, the more expensive the car is. And you can see also here the cab weight. The more heavy the car is, the more expensive it is. So you can see that linear trend right here. Again, all the code is available on this notebook. The links will be in the description of the video. So good. So once we have that done, I'm simply going to go ahead and scroll down here. You can see the different other data types. You can see city CPM, okay, the horsepower and the price. So it has a linear trend. The more horsepower the car has, the more expensive it is, right? The more powerful the car, the more expensive it's going to be, and it's going to cost, right? You can see the highway CPM and the price of the car has a negative relation, because then the line is inclining towards the left side. So if you draw a straight line, it's going to be inclining towards the left right here. So that's a negative linear relationship. So good. This is price against this price is going to be a linear relationship. So we're not worried about that. A positive one. Okay. So you can see even the city CPM has a negative relationship with the price, meaning that if the city CPM is high, then the price is going to be low. If the price is high, then the city CPM is going to be low. Just like that. So that's a negative relationship. Okay. So again, I explained all this in my introduction to statistics with statistics with Python series. I'm not going to go into depth about that. Again, it's just to introduce you to the field of machine learning. Once you understand, you get interested in this field, you can go ahead and actually begin to learn. I have a whole series where I explain things in much more beginner level. This more I just explain to you things to using a project perspective. But I have another video where I explain things from a very fundamental point, and I'm going to leave the link to that in the description below, we can learn all this from a very, very fundamental point. Okay, this a bit abstract point of view. Okay, so once I have that done, I'm just going to go ahead and scroll and let's see what you want to. So we can draw the different inferences from that data. We can draw the different inferences from here, and all this is going to be available on this notebook, the link in the description. Okay, so paste that code there and then let's run the code and let's see what we get. So we're doing the number of numeric features and their correlation. So again, I'm not going to talk about what correlation means. That like correlation basically just tells you how strong the relationship between two variables. So correlation just simply tells you how the relation between two variables is strong, like how strong is the relation between two variables, and that's basically what correlation is. Again, I have a whole series on data analysis with Python, so you can check that out where we go over the latest statistics and all that stuff like that. So that's basically it, and this is just a correlation matrix, and you can see the relation between the two. So for example, let's see the correlation between the let's see a very strong correlation. So the correlation between the bore ratio and the price of the car is 60% correlation. So you can see the bore ratio, we trace all this all the way to the side, and then finally we can trace it down to the price. So you can see it's 60%, right? So 60%, 0.6 or 60%. The correlation between the horsepower and the price of the car is 80%. So there's a strong relation between the correlation of the horsepower of the car and finally the price of the car. So the more powerful the horsepower is, the more expensive the car is. Okay, that's basically how you can interpret this correlation matrix. As you can see, also there's a 90% correlation between the size of the engine and the price of the car. So the more bigger the size of the engine is, the more expensive the price of the car is. The more expensive the car is, basically. You can also see you have negative correlations and other stuff like that. Okay, so this correlation matrix basically tells you how strong is the relation between two variables. Okay. Okay, so I'm not going to go into depth about this. Again, I have a whole tutorial about data analysis, so you can check out that video where I explain things in much more depth. But for now, this is basically it for about correlation. So let's move on to the next graph and let's see which graph we can draw to explain stuff. So also, weak correlation does not mean that we have to drop the feature. Basically, in machine learning, sometimes we can have a weak correlation and we need to drop features that do not have a strong correlation with our data. But in this case, we're not going to go ahead and drop any feature because the weak correlation does not necessarily mean that the data is not the feature is not important to determine the price of the car, right? So the feature can be important but can have a low correlation, and the other methods to decide whether to drop that feature or not, and I covered that in my other videos, so I'm not going to go it over in this video. So okay, this is an introduction part to data science, just giving you a brief view of what data science really is and what machine learning is in case you decide to pursue it. Okay. Okay, so once we have that, I'm going to go ahead and get you need to do some what you call feature engineering. So feature engineering, what basically does is that we can combine different features to make new features, and that's called feature engineering. So combining the existing features to make new features that can give us a better correlation and stuff like that is called feature engineering. And again, I have a whole series on feature engineering on my channel. Okay. So we're going to generate a new feature, okay, a new feature column, and you're going to call this feature column fuel economy. So I'm going to simply paste it right here. But before I paste, let me just make sure that I indicate that this is a part for feature engineering. So let me just indicate that feature engineering, just like that, and press enter. So I'm going to go ahead and paste that code here and then run the code. So this basically we're generating a new column called fuel economy column, and it is basically fuel economy is just going to be the fuel price of the 0.5 times the city mpg, and I told you what city mpg of the car means, plus 0.45 times the highway mpg. So this is just some information that you get by doing research, because you're not a car expert, right? But people who work in the car industry can know this thing. So you have to do a bit of research, and I found this by doing research. You can find the different information that you can use to generate new features about different columns. So just with information about cars. If you know any engineer or anyone who working in the industry, you can just contact them and ask them about it. But in this case, I just did a quick research and I found this information. I will calculate the fuel economy of the car, and that's is that you're using that to generate a fuel. You're using that to generate a new column. And let's try to see the correlation matrix of this. I'm going to copy this and go in here and simply paste it in here, and let's run the code and let's see what we get. So we're just plotting a simple graph to show the correlation between the fuel economy and the price of the car. So you can see the fuel economy and the price of the car are negatively correlated, meaning that there's a weak relation between the two. They're not positively correlated, they are weakly correlated. So that's basically it. And yeah, and you can see all these ones on the main axis are post 100% because price is 100% correlated with price, right? So yeah, that's this the correlation we can take from the fuel economy and the price. So if this correlation is negative, doesn't mean we have to drop it. No, it doesn't mean that. We can use it even if it's negative. Okay. So once you have looked at the correlations and we have generated, you have done some feature engineering of one column. In real, if you're doing a serious project in data science, you might have generated multiple features and not just a single feature. So if you scroll up here, you can see I've given a quick summary of the different feature selections that you're going to use. So just by examining the data, from examining the data, I came up to all these features that I'm going to use, and I'm going to drop the rest. So these are the features I'm going to use. And why did I choose to use these features? So I chose to use wheelbase because it has a high positive correlation with the target feature, which is the price. We have fuel economy has a high, actually a high correlation, but it's just a negative correlation, but it's actually a high correlation with the price of the car as well. We have the engine type, which also has a correlation. And I got all this from the matrix that we drew up here. So if I go back to the code right that we have here right here, if I scroll up, and you can see I draw the information right here. Just I got the information from this graph right here. Okay, so just select the information based on correlation and explain all this in my introduction to statistics machine learning for machine learning in Python series. Okay. Okay, so once we have that, we can see the car weight has a strong positive correlation. Just by examining the data, I chose the ones that have a strong correlation, okay, whether a negative or positive, and these are the columns that I decided to use. So we're going to go ahead and select just this column. So how do you select the columns? We're just going to go ahead and do this, and which is going to go ahead and select the columns that you want to work with. So I'm just going to go ahead and copy that and paste it right here. So I'm going to scroll here and simply paste it right here. So just paste it right here, and you can actually give this create a column. You can say this can be feature selection. So based on the graphs that you drew, we are able to select these features as good for us to be able to use to train our machine learning model. So we have selected just 16 features out of 27 features, right? That's 27 or 26 features. We have selected just 16 to use. So in machine learning, sometimes you might drop some features because based on your data analysis that you have performed so far, we have seen that those are the important ones, and we can decide to get rid of other ones. Okay. So yeah, that's basically it. We have just done some feature selection. So once you have the feature select that you want to use, you can go ahead and actually select the actual features which you're going to do right here. So we're going to just copy this line of code to select the features that you want to select. So I'm going to go ahead and simply hit control select all that and simply go in here and simply paste it in here. So paste it in here and run the code. Again, all this code is available on the GitHub on Google Colab, and you can find the link to all this in the description of the video. So this is a features underscore df. So if I do dot head, and let's see what you get. So if I do that, you should just see the first 5 rows. I explained to you what the head method does. Okay, so I just return to the first 5 rows. So you can see just these are the features we selected. So we selected to use the aspiration, the fuel type, the brand, all that, the bore ratio, the car length, the car width, the car height, the car height, and we're using all that to predict the price of the car because those are the important features that we notice from our data analysis, and that's why we do data analysis before building our machine learning model. So once we have that information, we are good to go. So let's see what's next for us. So okay, so once we have those features selected, good, we are good to go. So now we can simply go ahead and let's see what we need to do more. Yeah, we have looked at the data. Now you can we have 16 features. Okay, so good. So now this I can also check the number of features that you have. You do the shape, right? So if I go in here, I can just do df dot shape, and shape returns the number of rows and number of columns. The number of rows, 205 rows and 26 columns. So actually this is not df. I want to do selected. Okay, selected, paste that, and then sorry, not there. So delete this and paste it there and run the code again. So it will now get 16 16 different features, but 200 and 205 rows. Okay, so it was 28 features, but now we have dropped them and just we're going ahead with 16 based on after doing our data analysis. So once we have that done, good, let's go on to looking at some dummy encoding. Okay, so let me just copy the code and explain to you what this dummy encoding function does. Okay, let me just copy the code and paste it right here. Good. So let me explain to you what dummy encoding is. So we can, if you look at our columns right here, for example, if you look at this number of columns right here, the aspiration, the fuel type, the brand, the cylinder number, the engine type. All these are just numeric, textual data, right? So computers don't understand textual data, so they have to store this data in a numeric format. So how do we do? What we do here, we do something called the one hot encoding, or there's also something called dummy encoding. So I explained all this in my data cleaning and preparation videos or introduction to machine learning. So what basically that we simply do is just replace this with numbers. Okay, so I'm not going to explain to you what dummy encoding is. You can check out the video on introduction to data cleaning and preparation for machine learning. The link is gonna be if I remember, I'm going to keep the link in the video. Okay, so you can find it on my YouTube channel. So I'm going to simply copy the code and simply go in here and paste that. So now you are calling this function and you are changing the expression column, which is now numeric. You are changing it to the feature that you have encoded. Okay. Okay, so we're passing in a fuel. We want to pass in the fuel type. We want to encode that column, and you're passing in our data frame. The brand, you're going to also encode that information. It is by using pd.getDummies, which is pandas.getDummies, and just encoding that information. Okay, I explained all this in my introduction to data analysis machine learning series. So if I now scroll to the bottom, you can see now our data has now been encoded. So if I choose df, if I paste selected, let me just delete this run right here. So this selected, and then I select dot shape. Let's check the shape. Now that you have one hot dummy encode, you can see we move from 16 columns to now we have 47 columns as a result of doing dummy encoding. So that's basically how a dummy encoding works. So I'm not going to explain it in depth again. Detailed explanations on my YouTube page on my introduction to data cleaning. Okay, series. Okay, so once I have this done, let's look what we are missing. So we have everything that we need. So now we're going to go ahead and do what we call scaling and normalization. Okay, so if you go ahead and look at the price column, right, you can see the difference. The difference between the minimum and the maximum can be really high. So if I do the selected, so if I do selected underscore features underscore df dot price dot mean, let's check the mean. And if you run the code again, let's see what we get. So it's going to return to us the mean price, and then copy this and paste it right here. And let's try to get the max instead of the mean. So if I run the code again, and now we're going to return to us the max price. So you can see the difference between 5,000 and 45,000 is really a huge difference. So if you are training machine learning models, the AI can find it difficult to understand this kind of huge differences. So we need to bring it to a much simpler scale for the machine learning model to understand. And this is what we call min max scaling or normalization in machine learning, or scaling or normalization in machine learning. Again, I explained all this in much depth on my introduction to statistics and data cleaning and preparation in Python series. Okay, so I'm going to say scaling, data scaling. So let's say scaling and normalization, or scaling or normalization, and press enter. So now you have that done. Let's go ahead and get the code from here. So I'm just going to go ahead and select these features. We're going to first going to put sklearn preprocessing. We're going to import min max scaler. So I'm going to go ahead and import it. So I'm going to say from sklearn preprocessing import this min max scaler. Okay, min max scaler, just like that. And once I have that, I'm going to paste the code I copied and run the code again. So run that cell. So now you're going to simply now we did a simply min max scaling. So if I go ahead and copy this code right here and paste it right here, and I run the code again, now you can see the mark should be let's see, df out has no. Okay, so I made a typo right there. So let me just go in here. So we select everything and delete and paste it properly, and then run the code. So now you can see the max is 1, and this is the maximum value, and the minimum value will be something 0 point something. So that's basically what min max scaling does. Okay, and I explained all this in my introduction to data cleaning and preparation in Python series. So if I run this again, now you can see that the minimum is 0, while the maximum is 1. So we have scaled the number between 0 and 1 instead of 45 and 4,000, which is really 5,000 and 45,000. That's really a huge difference. So now we have a number between 0 and 1. So these smaller numbers are easier for the machine learning model to understand. So if I do selected underscore features underscore df, and if I do dot head, I should now see everything has been scaled, because we have scaled all these features right here. So 0 point, the maximum will be 1, anything else will be between 0 and 1. So we have just scaled that, so it's easier for machine learning models to understand smaller digits rather than huger ones. So, okay, so that's why you have to do scaling. So once you have scaled the data, we are good to go. So let's see what's next on the list. So once you have that, you're going to now split our data into training and testing sets. So basically what we do is simply we need to check if our machine model has learned something. So how do we do it? We take some data that we put aside that we don't show it to the machine learning model, so that after training we can use that data to test it to see if it has really understood the data, if it's really generalized well. Like for example, if you're going for an exam, right? You learn in class and the teacher gives you some questions to practice with, right? But if you go into exam, you're going to meet questions that you have never seen, like probably you haven't seen before. That's to test your understanding whether you have understood the concept that they have taught in class. So it's very similar to the same thing you're doing right here. Because if you give the if imagine your teacher gave you the same questions as in class exercises, then you probably get 100% in your exam, right? Even if you don't understand anything from that exam. So that's basically what we are doing right here. We are splitting the data so that after training the model, we can test it on data that it has never seen before to see how it's going to perform. So let's go ahead and split the data. So we're going to import from sklearn.model selection. We're going to import train, test, and split. So I'm going to go in here and just go and say we're going to go ahead and create a text, right? We're going to say this is going to be data splitting, just like that, and you're going to go ahead and simply say from sklearn.model let's go selection. You're going to go ahead and import train underscore test underscore split, just like that, and run that cell. So I'm going to paste the code that I have in here, and you're going to split our data into two parts. So you're going to have x and y. So if I go back into this graph, right, you can see that you have x and y. So we're going to go ahead and use the same concept, right? You're going to split our y, which is going to be the price that we're going to be trying to predict the price. And now x is not going to be just a single feature, but a collection of features, right? So, and that's basically what we're going to do. So x is just going to be the price, and y is going to be everything else other than the price. So good. That's basically what you have done right here. So that's basically the same concept is what you're using right here. But now x is just multiple variables, and that's what we call multivariate linear regression. Okay, so if it's a single variable, we call it single variate linear regression. So once we have that, I'm going to run that cell. And once I have the cell running, I'm going to go ahead and split now the data. So I'm going to copy this code right here, select all this, and I'm going to go ahead and paste it in here. So I'm going to go ahead and paste it in here and run that cell. So we're going to split our data into training and testing sets. You're going to use 80% for training, and the rest 20% you're going to use it to evaluate how well the model has generalized, right, to test the model. Okay, good. So once we have that done, what next are we going to do? We're going to you can check the shapes if you want. So you can do x train. You can do x underscore train dot shape, and then simply the shape, and then run that. This is going to return the number of rows. We are going to use 164 rows for testing, for training, and you're going to use let's do x underscore test dot shape. You're going to use the remaining for testing. So we're going to use 41 rows for testing the model. You're going to use 164 rows for testing, for training the model. Okay, just to see how well the model performs. So good. So once we have that done, let me just scroll down here and we see what we have. So now we can go ahead and begin to build our machine learning model finally. Okay, so that's basically what how machine learning is. You spend a lot of time doing data cleaning, data analysis, and just a fraction of the time for model building. So you're just going to see how fast you're going to get done with this model building just soon. So let's go ahead and create a cell just to indicate that we are building the model from this section onwards. So let's create a cell here. Going to see simply say it's going to be model building. Okay, so model building section, just like that. So now let's see what we need to import. We need to import a couple of things. So I'm just going to copy everything that I'm going to from here, and I'm going to explain to you what it all means. So again, copy everything and I go and paste it in here. Okay, so I'm going to go ahead and paste it in here. So I'm going to paste it in here and then simply run that to import everything. So once you have everything imported, all the libraries you're using from sklearn, which is the machine learning library that you're using. So sklearn is a library in Python that you're using for machine learning. So from sklearn.linear model, you're going to import something called a linear regression. I told you this is a linear regression video, right? So we're importing a linear regression model, and you're saying import stat models.api.as sm. This is just for statistics, okay? Stats module is a module we use in Python for statistics. And also, you're going to say sklearn.feature selection. You're going to import RFE. So what does RFE stands for? RFE stands for recursive feature selection, feature elimination, and I'll explain to you what in depth what it actually means. Okay. So once I have that, I'm going to go ahead and create a model. So I'm going to create an object of that of a linear regression class. Okay. So let me just go ahead and create the model. So I'm going to go in here and I'm going to say, let me say linear regression is going to be going to say linear. And we studied all of this when we're talking about how to create objects and object-oriented programming in Python. So I expect you guys to know this. Okay, so we're going to say l.fit. You're going to pass in x underscore train. We're training our model, so passing x train. You're going to pass in y underscore train. So passing it to it their features and their labels, right? So this is a supervised example of supervised machine learning, and I explained to you what supervised machine learning is. You provide the features along with the corresponding labels so the machine can learn from existing data with your concept features and corresponding labels. Okay. So if I go ahead and simply run that, so that's all we need to do. So this we created an instance of the model, or an instance of the linear regression model. And this basically we are training our model. So now our model is trained. So now we can go ahead and do prediction. So now we have an AI model. It's just that simple. So building a model is actually very, very simple. And the most important thing that takes a lot of time is actually doing the data cleaning and analysis part. And that's the most crucial part, because building the model is just a fraction of the second. So just by using these two lines, we have simply built an AI model. So congrats. Maybe this is your first time. Then that's a simple way of building a machine learning model. So good. So now let's check the score of the model. So to check the score of the model, I'm going to simply copy everything from here and so let me see. I think I split this into two windows unintentionally. Okay, let me see how I can bring this together. See, I can bring this together. So let me just bring it into the old one right here. Okay, so I have that done. So let me just go ahead and copy everything from here. Okay, so let me just make sure I deleted an alias. Let me just put back that L. So copy everything from here. So copy it, and then I'm going to go into our model training part, and I'm going to go ahead and simply paste it in here. So scroll down, and I'm still going to go ahead and paste that code in here. So this is just going to allow us to check the score. Basically, how well is our model doing? And how do you check the score of the model? You give it a data that it has never seen. Basically, you can think of this as giving a test to the model. So right, in school, your teachers will give you a test based on questions that you have never seen, or but basically the same methodology of finding the answers that they taught in class, right? So something very similar to this. So you're saying the linear model object dot score, and you're passing it the X test and the Y test. Basically the features and the correct answers to see how well it's going to do. So the model is going to do a prediction. It's going to compare its predictions with the actual prediction, which is Y underscore test, right? So it's the actual the truth predictions, and the model is going to generate its own predictions in the background and compare it with this truth one to see the score. So let's actually run this and let's see what's the score. So our model has an 88% score. So it has an 88% accuracy on predicting the price of the car given the features of the car. Okay, so good. So what features of the car are we giving the are we giving it this are we giving the model this one right here, the horsepower, the city, MPI, the highway, and all that information is what you give your feeding the model, and the model is able to come with a prediction with an accuracy of 80% accuracy. So good, that's really good. So once we have that done, we can actually go ahead and work more on this. Okay, so I'm just going to put it right here. So we have the model being generated. Let's get a model summary, a summary of the model, and this is where we dive a bit deep into statistics. So run this. If I am just keep it some right here, this is gonna be model summary. So it's gonna be model summary, uh, just like that. So model summary, and run that. So this we are getting the summary of that model. So if I run the code again, we have that function defined. So now you can call the function and pass in the data that you want and try to get a prediction score for this model. So I'm going to select everything right here. For some reason, it keeps disconnecting from the window. Okay, so I want to keep it right here. Okay. Okay, so I'm going back in here and then just paste that code that I copied right here, and let's try to get the prediction of that model. So it's going to give us some statistics. So this is a code from statistics that I got that give us statistics of the model. Okay, so just adding the model constants and then finally fitting the model and all of that. So these are just some documentation, just some summary. Okay, so this is how you can check the model summary using the OLCL. Yeah, so that's all we need. Okay, so that's basically it. And if you scroll up here, you can see we have that information right here. So you can see we have R squared. So what does R squared stands for? The R squared is just something something that is used to measure a measure that is used, a value that is used to measure the accuracy of a linear regression model. So that's basically it. And you can see we have an R squared of around 80, 95%, 95.8, around approximately 96% R squared. Adjusted R squared is around 94%. So you can see all that. You can see the p values. I don't want to go ahead and talk about the statistics of this. Because this is an introduction course, so I'm not going to talk about the statistics of these models. Okay. So these are the statistics that we can use the p-values to decide which models to choose and which one to drop. And I don't want to go into the statistics because it's just an introduction part. Okay, so you can use the RF to choose which features you want basing on the p-values and stuff like that. You can do that right here. So basing on the p-values, we are going to use the RFE. So RFE stands for recurrent uh, feature elimination. So we talk about recurrent function, right? Something that calls itself. So it's going to do this over again. So we're going to take a model, train the model, and we tell you that we want a maximum number of 30 features. So it's going to drop the features that are not important. So it's going to first go on the first instance. It's going to take a model, train it on all the features, drop a number of features that are not important. Again, take the number of features that are important that it's found from that iteration, train another model, get the number of features that are important and drop the rest that are not important. And it's going to do this amount of time until you're left with 30 features, because right now we have around 40 something features. So it's going to do this repetitively until we are left with around 30 features. So once we have that done, let's see how we can see if the model performance is going to improve. So you can see the features that this model selects by using this code right here. So if you copy this code and paste it right here and run it, you can see it's going to return to you the features that it selected and the ones that it dropped out. So that's basically it. Okay, so once I have that done, you can also go ahead and actually check the features that the model selected. You're going to use the features that the model selected to select to do basically pick the features that the RFE, the feature recurrent feature elimination, tells us that is good. So these are the features that the model the RFE tells us that is good, and you're going to drop all the rest that it says is bad. So you can see all the places that have false means that the features are not good, so we should drop them, and we should go with the ones that are true, which are basically these features right here. And you can see all the ones that are true, you're going to go with them, and this is how we pick them up from the features. So we have the RFE selected features. So once you have those features, you're going to go ahead and use those features now to train again a regression model, and let's see how the performance is going to increase or drop. So I'm going to copy that, paste it right here, and run that code. So let's see if our performance is going to increase or drop. So you can see our performance has increased by 1%. So now we are moved from 88 to 89% accuracy in our model. So good. But the linear model, the best thing to use to determine the accuracy of the linear model is just the R squared. Okay, the R squared, you can use the R squared. Okay, it's a good measure. So that's basically it for that model. You can also make predictions and other stuff like that using our model. So let's try to make, you can see we have an R squared of 95%. I told you earlier on. You can use the p-values to drop. I don't want to go into deep into statistics. You need, if anything is good above, if the p-value is above 0.5, it's not a good. It has to be below 0.5, but you're not going to go ahead and do all that. Okay, so I'm just going to keep things simple. And this is how you can make predictions. Now our model has learned. Let's try to tell our model to make some predictions. So we're going to tell our model to make some predictions of the test, which is the data that it has never seen before. So we're going to tell it to make a prediction on this test data using the features that has been selected by the uh, RFE features that we selected. So once I have that done, I can just tell it to make a prediction, and you can see these are the model's prediction of the different prices that the model predicted basing on the features that are within this data frame. So once we have that, we can simply go ahead and get the R score. So I'm going to copy this and paste it right here and run that cell, and that's going to return to us the R score, and you can check the accuracy by using this function as well. So you can just copy that, and you can go in here and just paste it right here, and you can go ahead and check the R score. Okay, the R2 score. So this is basically the R2 score of an 89% accuracy. Yeah, so that's basically how we can build a simple linear regression model to predict the price of the car. So that's basically it for this video. Again, it was a lot of stuff to go over. This is just to give you a quick overview of what machine learning basically is. If you want to understand the machine learning from a fundamental point of view, I have a lot of I have a lot of tutorials on it. I have a lot in the ones introducing you to how to use pandas, a one introducing you to statistics, the one introducing you to data cleaning and preparation, and then finally I have the one for introduction to machine learning, where I go over things from a more fundamental level. I went this in here. I went over things at an abstract level, and we didn't type out code by code because it would take a long time to do that. Okay, so imagine us we had to type out all the code. The video would be extremely long, and I didn't want that. That's why I had to copy and paste the code to keep things short and focus on explaining things to you. Just to give you a general idea of what machine learning is. Okay, so this is what machine learning basically is, and this is what we're doing most of the time in machine learning. Okay, so I hope this video gives you a good understanding of machine learning, and I advise you to check out the fundamentals video if this field interests you more. It's actually very interesting. Here I might go over things briefly, and you might not maybe uh, have a good grasp of stuff, but check out the fundamental videos. I'm going to leave all of them in the description, giving you the step-by-step instruction of everything. If we go in that in this series, you go ahead and type every line of code by code. Okay, so you can check out that video, and yeah, that's basically it for this video. So if you guys you find this helpful, make sure that you like the video, you subscribe to the YouTube channel, and also let me know of any comments and suggestions you have in the comment section. I'll do my best to get back to you. Thanks for watching, and see you in the next one. Keep safe.